fingertips. All you have to do is go to Blackboard, go to coursework, and then go to the appropriate lesson, which is Module 1, Topic 2, sequences and patterns. Exactly what I have typed in Blackboard so you can follow along. Everything's titled the same. Go ahead and jot down this terminology. Okay, we're going to continue on. There's going to be more terminology on the next thing. That's just going to kind of be a preview of what we're going to be doing in this video.
Let's find out how much Math Dragon knows about sequences. What strategies could you use to match an expression with its corresponding sequence of numbers?
You can evaluate the expression using the numbers 1 through 5, and then look for the sequence of numbers that matches these values.
What does n represent in the following expression? 2n plus 2.
N represents the position of the number in the sequence.
So we're going to be talking about plugging in numbers 1, 2, 3, 4, 5 into an expression like 2n plus 2 to find a sequence.
What strategies could you use to match a sequence of numbers with its corresponding expression?
I could find the rate of change between consecutive numbers in the sequence and try to write my own rule.
Time to practice. When we first learn about sequences, we learn about patterns. Determine the next 3 terms in each pattern below.
Okay, so I want you to take some time to write down 1, 2, 3, 4, 5, 6. Write down what would be the next 3 things in the pattern, just like we just did in the entry task. Some of these are alphabetic, some are numeric, some are visual, okay? Number 5, there is a typo in there. See if you can figure out where the typo is in number 5. Okay, so let's see what we came up with. All right, this first one is alphabetic, of course. And we start at A, we skip B, go to C, we skip D, go to E, we skip F, go to G. So it's every other letter starting with A. So if we, I, what comes after I is J. So if you skip J, you get L. If you skip M, you get N. Is that right? I, J, K. Skip L, I'm sorry. If you skip J, you get K. Skip L, you get M. Skip N, you get O. So this should be KMO here. All right. Second one, that's pretty easy. You can see that we're increasing by 2 every time. So the next 3 numbers should be 15, 17, 19. In example 3, we are decreasing by 3 every time. In other words, subtracting 3. So negative 14 minus 3, that's negative 17, then negative 20, then negative 23. Okay. Number 4 might be a little bit of a challenge because, of course, this is the alphabet backwards starting with Z. So ZYXWV, what comes before V? It would be a U, and then a T, and then an S. So this should be UTS here. Number 5, we have a typo. I don't know if you figured it out, but if you go from left to right, we add 5, then we add 25, then we add 15, then we add 15. Okay, so the end of this thing, we're adding 15 every time. If this 26 was a 36, then we do 21 plus 15 is 36. 36 plus 15 is 51. 51 plus 15 is 66, and so forth. So this should be adding 15. So the next 3 numbers should be 96, 111, and 126. Okay. And then the last one, those are just arrows. So we have an arrow to the right, then we have an arrow up, then an arrow to the left, then an arrow down, then we go back to an arrow to the right. So We're following this pattern. So the next one should be an arrow up, then an arrow to the left, and an arrow down. Okay, how did we do?
Use the pattern shown in the figures below to answer the questions below. First, draw a picture of what building 5 would look like if you were to continue the same problem.
Okay, so here's building 1, here's building 2, here's building 3. So this is a visual one. This is a geometric one. What would building 5 look like? Okay, we don't have building 4. We just have buildings 1, 2, 3. Skip building 4. You're supposed to draw a picture of what you think building 5 would look like. If you want to draw building 4 to help you get to building 5, you're welcome to do that. What do you see happening here? What do you think building 5 would look like? Give that a shot. Okay, let's reveal the answer and see what you came up with.
Did yours look like this? If so, great job. Second, how many square tiles will it take to create building 10?
Okay, here's the real question. How many square tiles is it going to take to create building 10? Okay, so you might get this by continuing drawing pictures. You might get it some mathematical way, a numeric way, or you may use a table, something like that. So if you want to put your answer in the chat about how many you think it's going to take, that would be great. So far, 3 people have come in, 4 people have come in with the correct answer. 4 out of 5 are good. Good, lots of good. Yes, lots of people are getting the right answer. The interesting thing is, how are we getting this answer? So if you want to chat in that chat box, how you got your answer, that would be good. Person that didn't get it right, I responded to. If I didn't respond to you, that means you have it right. So if you have it right, whoops, don't reveal the answer. Go back.
Second, how many square tiles will it take to create building 10?
Good, so I see a couple numeric answers. Interesting. Yeah, there's some very creative ones, some straightforward ones. Okay. Good. So as many of you guys are just drawing more pictures that are bigger till you get to building 10. Others of you are finding a mathematical, numeric way to do it. Some are using multiplication. Some of you are using addition. That's good. Okay, I'm just going to stop sharing this for a second. One more answer. Good. And show you how I would do this, which is a little bit different, but it kind of leads into some things you're going to want to do. Whoops. Stop. I want to switch it. Okay. So I'm just going to show you a table way to do this, okay? So in one column, I'm going to put the building number. In the other column, I'm going to put the number tiles. So we've looked at that picture for a long time. When there was one building, there was 3 tiles, okay? When there were 2 buildings, there were 6 tiles. When there were 3 buildings, there were 9 tiles. Okay, you guys all saw that. We never saw a figure with 4, but building 5, you guys all drew it, and there was 15 tiles there. So you probably can see a pattern developing here. Every time we add a building, we add 3 more tiles. So if I would have drawn the building number 4, it would have had 12 tiles in it, okay? So I can just extend this pattern until I get to building 10. So that's one thing that's nice about a table is you can extend the pattern. I already have 1 through 5, and now I'm going to add 6, 7, 8, 9, 10 and extend the pattern. So if I add 3 to 15, I get to 18. If I add 3 to 18, I get to 21, and then 24, and then 27. And so building 10, when I extend that pattern, building number 10 has 30 tiles. Okay, a lot of you guys did other things. You said, hey, if building 5 has 15, 5 plus 5 is 10, and so that means if I add 15 to the 15 I already have, I get 30. A bunch of you said that. Some of you said, hey, building 10 has 10 rows, and they're all 3 high. 10 times 3 is 30. Okay, so some of you guys use the area model, which is good. All right, back to the pattern building. Here we go.
Did you get the answer 30? If so, you're on the right track. Sequence matching. Draw a line that connects each equation with its sequence of numbers. The first one has been done for you.
Okay, so you guys are going to try to figure out what matches with what.
The first one has been done for you.
They already matched 2x plus 3 with this sequence down here. How did they do that? Okay, well, we talked about earlier, the dragon talked about substituting 1, 2, 3, 4, and 5 in for x and seeing what those first 5 numbers are in the sequence. So in other words, if I substitute a 1 in for x, 2 times 1 is 2, and then 2 plus 3 is 5. So that's a 5. Well, this sequence up here starts with a 5. None of the other ones do. What if I put in a 2? Well, 2 times 2 is 4, and 4 plus 3 is 7. So the second number in my sequence should be 7, which is true on this one. And then if I put in a 3, 2 times 3 is 6, plus 3 is 9. So that is why this first equation matches with the last sequence. Your job is to figure out the other 4. Let's see how you do on those. Seeing some good guesses in the chat. I appreciate that. Remember, what you're doing is you're substituting the numbers 1, 2, 3, 4, 5 in for x and see which sequence it actually produces. Okay, so let's just take a look at equation number 2. If I put in a 1 for x, 3 times 1, 3x means 3 times x. So if x is 1, that's 3 times 1, which is 3, and 3 minus 1 is 2. So this second equation should start with a 2, which is the first sequence. But let's just make sure the rest of these numbers are correct. Put in a 2, 3 times 2 is 6, minus 1 is 5, so 5. And then put in a 3, 3 times 3 is 9, minus 1 is 8. Oh yeah, that works. So the second equation goes with the first sequence. What about x plus 4? Okay, I saw some people said it should be this one right here. Well, let's see. What if we put in a 1 for x? Well, 1 plus 4 is 5. Oh, wait, first number should be 5, not 9. What if I put in a 2 for x? 2 plus 4 is 6. How about a 3? 3 plus 4 is 7. So this one right here, 5, 6, 7, 8, 9, that's the third one. The third equation goes with the second to the bottom sequence, 5, 6, 7, 8, 9. And what about equation number 4, y equals 4x plus 5? Well, if we put in a 1 for x, 4 times 1 is 4, plus 5 is 9. Put in a 2, 4 times 2 is 8, plus 5 is 13. Put in a 3, 4 times 3 is 12, plus 5 is 17. So Equation 4 seems to go with the second sequence. So here we go. Let's see what you got compared to the key here.
Your finished diagram should look like this.
Here you go. There's the correct answers. How did you do? You get all of them right, most of them right. Didn't get any of them right, but now it makes sense. Okay. Let's keep going.
Let's see how much you have learned. Now create a pattern of your own that contains at least 5 terms. Try to explain the relationship in the pattern. An example has already been done for you.
Okay, so make up your own pattern. Write a numeric pattern and explain in words what you're doing to get from one to the next. While you're doing that, catch up with what's in the chat. Good. Thank you for your responses in the chat. Oh yeah, there is one mistake in that numeric pattern. Maybe you can find it. You think you know what the mistake in that numeric pattern is? Just put it in the chat. Let's see what we got. Good, Charles. That's good. Okay, the mistake I see here, we're adding 15, adding 15, adding 15. That's really good. Until 96 plus 15 is not 101. It should be 111. And then 111 plus 15 is 126. So they got their last two numbers wrong. Okay, continuing on.
Sequence buildings. How many tiles are needed to build figure 35 in this pattern? Justify your answer.
All right, give this a try, okay? Here's figure 1, here's figure 2, here's figure 3, here's figure 4. What I want you to do is look at that pattern. I don't know if you really want to draw 35 of these, but you want to figure out how we can figure how many tiles it takes to make figure 35, probably without drawing. So hopefully we can do it numerically, in a table, algebraically. How can we do this? Oh, a couple people got it. 3 people got it in no time at all. Nice work. Good. Everybody's getting it right so far, which is awesome. Good, Charles. I like your explanation. Lots of correct answers. Just how are we getting it that quickly is the question. Are people drawing pictures that fast? I doubt it. So there must be some connection between the figure number and your answer. Anybody else got a response for me? All right, so I'm gonna share my document camera to show you how I would do this one. If it was me, again, I would make a table. I love tables. Tables are and they just help organize things. You can just put everything. So in the left-hand side, I would put the figure. Let's get that up so you can see it. So figure, and over here I would do tiles. okay? So figure 1 had 4 tiles, okay? You had 3 across the bottom and then 1 going vertically. In figure 2, we had 5 tiles. It had 3 across the bottom and 2 going up. Figure 3, 3 across the bottom and 3 going up, and then figure 4 had 3 across the bottom and 4 going up. So we had that. But you can start to see a pattern now, okay? So figure 5, of course, would have 8, figure 6 would have 9, figure 7 would have 10, because of course, every time we add a figure, we add in 1 more tile, all right? But you might make a connection even between the number of tiles and the figure number, okay? You notice the number of tiles is always 3 more than the figure number. 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7. So rather than extending this whole table all the way down to 35 like we did on the last one, I'm seeing the connection between the input and the output. We're just adding 3. So 35 plus 3 would be 38. So there's that. Now, some of you guys noticed, I think, from the pictures that there's always 3 across the bottom, and then the number above that is the figure number, okay? So like figure 4, there's 4 tiles above the bottom row, and so you just added the figure number to 3 because of that, okay? But I like that table as well. Helps me to make a connection and organize my thing. All right, here we go.
Sequence matching. Draw a line that connects each equation with its sequence of numbers. The first one has been done for you.
Okay, we've done this before. Let's see if we can do it with new algebraic expressions and new sequences. Which of those 4 that aren't matched already match up with which? Good, some of you are putting your responses down there in the chat, trying to respond to those. Okay, good. So this n plus 2, if you put in a 1 here, 1 plus 2 is 3. So it's got to be the one that starts with a 3, but let's just double check. If you put in a 2, 2 plus 2 is 4. Yeah, so this number 2 goes with the third star here, okay? What about number 3, 2n? Well, if you put in a 1, 2 times 1 is 2. If you put in a 2, 2 times 2 is 4. If you put in a 3, 2 times 3 is 6. So which one starts out 2, 4, 6 is right here, okay? So number 3 is this fourth star down, okay? Number 4, 4n plus 4. Again, if you put in a 1, 4 times 1 is 4 plus 4 is 8. So this one starts with 8, which this one does. So let's check it out. 2, if you put in a 2 for n, 4 times 2 is 8 plus 4, that's 12. So that seems to be working. So number 4 goes with the second grouping, which means the last one must go with that first one.
Draw a line that connects each equation with its sequence of numbers. Again,
this time the sequences are in a table form. So they've already matched up this first equation, y equals 5x, to this first table. It looks like what they're doing is taking the input and multiplying by 5. See, 1 times 5 is 5, 3 times 5 is 15, 7 times 5 is 35, 8 times 5 is 40. So see if you can figure out what equation matches which table. It's another way of thinking about a sequence, the outputs of the sequence. Good, Mackenzie. Yeah. All right. Good responses there. The last one. So if I look at the second table right here, 3 times what equals 9, 5 times what equals 15, 6 times what equals 18, 11 times what equals 33. Hopefully the is what is the same for each one of those, okay? And you guys probably know that it's 3. 3 times 3 is 9, 5 times 3 is 15, 6 times 3 is 18. So this second table here matches up with this one, y equals 3x, okay? If I could get this word out of the way here, just so you know, this is a 2, 4, 5, and a 7. So 2 times 2 is 4, 4 times 2 is 8, 5 times 2 is 10, 7 times 2 is 14. So this one is y equals 2x. Do the 3 on the right. Y equals 4x, what does that match with? Well, that's going to match this one over here. 9 times 4 is 36. 8 times 4 is 32. 11 times 4 is 44. And it turns out, yeah, 13 times 4 is 52. So y equals 4x is the top right. The middle one on the right is y equals 7x, and the one over here on the bottom right is y equals 6x. Okay, let's go on to the next.
And the first one has been done for you. Now let's look at some tax problems that have sequences. Which rule can be used to find the value of any term in the sequence below where n represents the position of the term? Represents the
Okay, so which one of these 4 algebraic expressions gives you this entire table? Okay, n is the position. So you have to plug in 1, 2, 3, 4 into each one of these and figure out which one's going to give you this sequence over here, the value of 6, 10. Which one of those is right? Better try more than just n equals 1. Okay, so if we just put 1 in, actually 1 works for all 4 of these, okay? So putting in 1 doesn't help because it works for all of them. You get 6 no matter which one of these 4. But if you put in 2, for A, 2 times 2 is 4 plus 4 is 8. So A does not give you 10 like you want. If you put 2 in here for B, 4 times 2 is 8 plus 2 more is 10. That does work. For C, 3 times 2 is 6 plus 3 is 9. So C doesn't work. And for D, 8 times 2 is 16 minus 2 is 14. So that doesn't work. So it's B. B is the one that works for all of those.
position of the term. Which sequence follows the rule n divided by 4, in which n represents the position of a term in the sequence?
And this time they give you the rule. You have to figure out which one of those sequences is the right one for that rule, okay? instead of vice versa. So which sequence is n over 4, where n is the position of the sequence? And you can see they all start out correctly. N starts as 1, so you have 1/4 start for all of them. So you have to look at other numbers past that to help you figure out which is the right sequence for that rule. So one of the big deciders is when n equals 2. N equals 2 would be 2 over 4. Well, obviously A isn't 2 over 4. 3/4 is not 2/4. So A and C are both out. So it's either B or D. So how do I know which one it is? Well, as you know, 2/4 reduces to 1/2, right? 2/4 and 1/2 are the same. So B and D start out the same, 1/4 and 1/2. And then the next one, the n value is 3. It's the third thing, the third term, the third position. So that's 3 over 4, which is B. And of course, D is 1 over 1. But 1 over 1 is 4 over 4, so that should be the fourth one. So the answer is B. So good job, those of you that put B. Got one more here.
Which sequence follows the rule 8n minus 4, where n represents the position of a term in the sequence? In the sequence.
Okay, so there's the rule. Which one of these is the right sequence for that rule? F, G, H, or J? Okay, got a lot of good responses. If I put in a 1 for n, 8 times 1 is 8. 8 minus 4 is 4. So it's got to be one of these H or J that starts with a 4, because F and G are out already. Okay, put in a 2. 8 times 2 is 16. 16 minus 4, that's 12. So J goes 4 and then 12. Let's just check it out. Make sure 3 works. 8 times 3 is 24. Minus 4 is 20. So yeah, J is your right answer. Good job, those of you that put J. Oh, that's right. That's the last one. Okay. So that's the Math Dragon video. Of course, you guys can watch that. All you have to do is go to coursework and then module 1, pattern finding, and we're on topic 2 now. So over here in the table of contents, topic 2, recognizing patterns and sequences. Okay. So if you missed anything, you can go back and watch that. Now we're going to watch the last video. It's about 10 minutes. I'm going to skip the first minute, and then you guys are going to see a series of patterns, and she'll start with some vocab, so I'm going to have you write that down. And then we'll go through some patterns with her as well that I want you to take notes on.
Today's lesson
We're going
in
to skip
the
the
sequence,
first minute.
you need careful eye. Here's our vocabulary.
Okay, here's the vocabulary that she wants you to jot down. Okay, these are terms you've seen before. We saw it at the beginning of the last video, but now that we've seen a bunch of examples, it might make a little more sense. Maybe this is a little more organized the way they're laid out, table, if you want to put them like that, now that we've seen some examples. She's going to talk about these, and you can jot this down while she's talking. And of course, as you know, you can come back to this video on Blackboard on your own anytime you want.
For today. The first word is sequence. A sequence is an ordered set of numbers. The way that I know if a set of numbers is a sequence is if I can identify a rule and predict what comes next. So let's take a look at this sequence. I can see that to get from 10 to 13, then I'm going to do plus 3. To get from 13 to 16, it's plus 3, and 16 to 19, it's plus 3. So I can predict that next will be 22. So it is a sequence. A term is what we call each number in a sequence. So I have the same sequence. I'm just going to point to 10 because 10 is a term, the first term. 13 is the second term, 16 is the third term, and 19 is the fourth term. An arithmetic sequence is when numbers in a sequence go up by the same amount each time. So it has to be an addition pattern, but not only that, we have to add the same amount each time. We already decided up here with this pattern that we added 3 each time. So it is an addition pattern, and we're adding the same number each time. So that is an arithmetic sequence. All right, let's go ahead and try a little exploration here. Here's our problem. I began building the following pattern below with toothpicks. Each day I continue the pattern. How many toothpicks will be in the design I make on the 7th day? We're going to fill in a table to help us figure this out. So I created a table. The top row tells me what day it is, and the bottom row tells me how many toothpicks I need for that day's figure. So on day 1, my figure looks like this. So I think I'm just going to go ahead and put in the days. So it's going to be day 1, 2, 3, 4, 5, 6, and 7. So let's look at how many toothpicks I needed on day 1. 1, 2, 3, 4. So day 1, I needed 4 toothpicks. Day 2, I need 1, 2, 3, 4, 5, 6, 7. Okay, on day 3, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10. Now, hopefully you're noticing that we have the same figure we did the day before. So I already know that this will take 10. And then I'm just adding 3 more. So the 4th day is 13. I can also look at my table here and say, how do I get from 4 to 7? That's going to be plus 3. To get from 7 to 10 is plus 3, 10 to 13 plus 3. So I can tell that my pattern is to add 3 each time. So 13 plus 3 is 16, plus 3 is 19, plus 3 is 21. So I know that on day 7...
Oh, but you're screaming, no, it's not 21. You made a mistake. 19 plus 3 is 22. This should be a 22. Yes, you did make a mistake.
I will need 21 toothpicks. If we do it visually and I ask you to draw what the next figure will look like, I'm going to copy this. So have 4. And then again, we just added 1 box each time. And now it's going to have 5. All right, let's look at another pattern. All right, so we have 96, 84, 72. Again, what I like to do is I draw like a frog jumping from number to number, and I tell what's happening to get from 96 to 84. I can see that I am subtracting 12. I could always use my calculator to see what that difference is. Now, we can't just stop there. We have to make sure that subtracting 12 continues to be what is happening. And sure enough, 84 minus 12 is 72. So I'm pretty confident that that's my pattern. So I'm going to continue to subtract 12 and get 60, 48, and 36. So if I was asked what my rule is minus 12. My next term is 60. All right, let's take a look at the next one. Now I'm going to look at how do I get from 1 to 3. Well, there's 2 ways. I can add 2, or I could also multiply by 3. So we need to keep going and see which rule continues to work. All right, so then from 3 to 6 is plus 3, and 3 to 6 is times 2. So I might say that I'm stuck and nothing's working. But let's keep going, let's keep writing what's happening and see if a pattern kind of pops into our head. I think you're going to see it pretty soon. Let's try addition again. 6 to 10, we're going to write what's happening, plus 4. 6 to 10 multiplying, that really doesn't work, so I think we're done with the multiplication. So let's go from 10 to 15 plus 5. Now I'm seeing a pattern. First we added 2, then 3, then 4, then 5. So I think we're going to add 6 and get 21. Then add 7 and get 28. Then add 8 and get, that's right, 36. Oops. All right, so, it didn't go up by the same thing each time, but when we wrote it out, we could figure out what the pattern was. All right, so just some hints for you that you probably got from the last video if you watched that as well. Look for an obvious pattern. If you're stuck, think about, do the numbers get bigger or smaller? List how much greater the numbers get.
I like this because it gives you some concrete things you can try if you get stuck, okay? You're going to be thinking about whether the numbers get bigger or smaller. Multiplying and adding is going to help you if things are increasing. Things are getting smaller or decreasing. You're going to think about dividing or subtracting.
Get by adding and multiplying so that you can try both and see what works. If we try addition here, we see it's plus 2, plus 4, plus 8. All right, well, that's kind of, I don't see much of a pattern there. Let's try this. Times 2, 4 to 8, times 2, 8 to 16, times 2. So when I write out both, I can see that this is what my rule is, times 2. So we can continue it. 16 times 2 is 32, 64, and 128. All right, how about if the numbers are getting smaller? Let's see how much smaller they get by subtracting or dividing. Which one works? Which pattern continues? 80 minus 7 is 73. 73 minus 7 is 66. 66 minus 7. That looks like it's working. And can I divide 80 by something nice to get 73? No. So looks like that's not going to work. So my rule is minus 7. My next term will be 52, and then 45, and then 38. All right. You have this sheet in your practice packet, so I'd like you to take that out.
You don't have the sheet, but you can certainly follow along as she's switching a sequence into a table.
And you are going to go ahead and do this with me. So I want to look at how can we take a sequence like this, 1, 9, 17, 25, and how do we put that into a table? All right, well, you're going to see tables that look like this, where it says position and value of term. And a lot of people don't understand what that means, so let me just show you. Position is, if you think about you're in line for lunch. Position is where are you in that line? Are you first? Are you second? Are you third? Well, think about these numbers as being in line. So the position 1 is which number is first in our sequence. So position 1 belongs to number 1. Position 2 is who's second? What number is second in our sequence? And that's 9. So which number is third or in position 3? That's 17. Then we could say position 4, 5, 6. The fourth number is 25. Now we need to figure out what's going to come next. So to get from 1 to 9, I'm going to add 8, 9 to 17, add 8. So plus 8 seems to be our rule. So let's continue that pattern. 25 plus 8 is 33, plus 8 is 41, plus 8 is 49. Then we can continue to fill in our pattern. The fifth number was 33, 6 was 41, and then I'm done with my table. All right, let's try this one. Again, position 1, 2, 3, 4, 5, 6. That means who's first in the sequence, second, third, fourth, fifth, and sixth. All right, this one is not as obvious. Let's take a look. 1 to 3 could be plus 2, or it could be times 3. 3 to 2 is minus 1. 2 to 6 could either be plus 4 or times 3. 6 to 5 is minus 1. 5 to 15 can be plus 10 or times 3. So let's figure out what's really happening. When the numbers get bigger, I don't see a good addition pattern, plus 2, plus 4, plus 10. So I'm going to cross that out. That's not working. But I do see that it's multiplied by 3 each time it gets bigger. I also see that when it gets smaller, it's always minus 1. So my rule is times 3 minus 1, times 3 minus 1, times 3 minus 1. So from 5 to 15, we just did times 3. Now we're going to do minus 1 and get 14. Then we're going to number, which is 3. Position 3 is our third number, 2, and then 6, 5, 15, and then we could continue if we had more room.
Okay, so that's a good amount of that video. Again, if you want to see the rest, you're welcome to watch the rest of that, okay? You go down to the bottom of the videos, it says, hey, proceed to Math Excel for school and complete the assignment patterns to sequences to tables. So that's where we're going to go is patterns, sequences, and tables. And so I want you to head there now, okay? So here we are on patterns or sequences, or here's the list of homework I have. Okay, and we're looking for the one that's called recognizing patterns and sequences. Here it is right below the quiz or the test yesterday. I'm going to click on that and the assignment's going to pop up. Assignment should. I got to go back. Okay. Recognizing patterns and sequences. Yes, that's what I want to go to. Okay, so let's check this out. Looks like I've already done some of these problems, but skip over here to question number 5. Let's see what that one. Oh, that's a figure, okay? It says find the perimeter when 98 triangles are put together in the pattern shown below. Assume all the triangle side lengths are 1 centimeter. So they show me 1, and they want to know what it would look like with 98 of them, okay? So maybe I'm going to have to do a little bit of work with this, okay? So maybe I'm not sure. So maybe I go to question help, view an example, and here they have some help. It says the perimeter is the sum of the lengths of the exposed sides of the figures. Find the perimeter of the pattern. Start by finding the relationship between the total number of sides of triangles exposed and the total number of triangles in the pattern. Okay, so in other words, right now I have 1, 2, 3, 4, 5 triangles. What is the perimeter when there's 5 triangles? Okay, and so you should start with 1 triangle and 2 triangles and 3 triangles, 4 triangles and 5 triangles, and then move along from there. So make the simplest one first, which is 1 triangle. When you have 1 triangle, the number of exposed sides of the pattern is 1, 2, 3. There's 3 of them. So each side is a centimeter, so that's 3 centimeters. Continue on. Here, there's 2 triangles. We just added another triangle, and there's the bottom and the left side that are exposed. The right side's no longer exposed because it's touching the other triangle. So 1, 2, 3, 4. So now when there's 2 triangles, there's a perimeter of 4. And then there's 3 triangles. Our perimeter is 5 because, of course, there's 2 across the bottom. There's the left side. There's 1 across the top and the right side. So 1, 2, 3, 4, 5. And then when there's 4, there's 2 across the bottom. There's 1 on the left, 2 across the top. There's 1 on the right. So 2 plus 1 is 3, plus another 2 is 5, plus 1 is 6. So you're starting to see sort of a table here, if you will. The left side is the number of triangles, and the right side is the perimeter, okay? And you might start to see a connection there. Maybe what you're seeing is that there's always 2 more in the perimeter than there are triangles. Okay. So there's another geometric way of talking about that as well. But this is saying, so if there's 72 triangles, there's going to be 2 more of that exposed, which is 74. So your answer would be 74 for that situation. Okay. But this is saying when there's 98 triangles, so if the rule is that you always add 2 to that, that would be 100 centimeters. Okay. So that's kind of what you're going to do here. You can draw pictures, you can make a table, whatever you need to do. Sometimes it's going to be a sequence. You just have to fill out the rest of them in the sequence. Some of them are going to be geometric like this. So I'm going to have you guys go ahead and go to breakout rooms and give these a start. So go to Math Excel for School. There's 7 multiple choice. Some of them have multiple parts. I'm going to put you guys all in a room. Make sure you join your room, and then if you have a question, you can